Ladies and gentlemen, I stand remiss unless I help correct one or two things in this model right now. The first of them was an aspect of expediency in the closing minutes of yesterday, when in our headlong attempt, successful attempt to incorporate some additional outcomes, we dispensed with the normal care for correcting the names for things. So you'll notice right now we have two constructs, quit attempts versus age at death for the graph, and a corresponding data item here. But if you actually look how we're using them functionally, those have those names, but the way we're using them functionally, when someone dies here within the model, we are adding into this thing called quit attempts versus age at death. Yes, age at death, but then the other thing is not quit attempts, but cumulative time till smoked. So we really owe it to ourselves. We owe it to my online followers to go change this to an appropriate name. I slept remiss last night. So I'd like you to go to main, I'd like you to go down main, and I'd like you to go now systematically change this. So where it says quit attempts here, we're going to say time smoking. Now you'll notice when I'm doing this, there's a little light bulb. Do you see that? See the little light bulb? Yeah? Okay. I'd like you to press...
Can you go back?
Sorry?
Can you go back one step? Or did you get there?
No, but I'll do it again in a minute. So I just said I changed it from quit attempts to time smoking. Okay, I typed it and I did Control Enter, and this is what it's proposing that it change it to every time it finds it. So I'm going to change it here, and now, ladies and gentlemen, it should have changed all references to it across the model. Okay, we're going to do it again. Okay, here we go. And I'm going to, instead of quit attempts, I'm going to say time smoking. Notice I'm typing it, and there's this little light bulb here. See that? And notice it says press Control Enter. I think on a Mac it's Keepers has just left the room. Is that Option Enter?
Option space.
Not for Control Enter. I think it's Option Return. Apple key return. Okay, so I'm pressing that, time smoking, and I'm going to say OK. And what it's doing is, ladies and gentlemen, each time it's finding it in the model, it's replacing it. Okay. Next, I'll go and I'll check. Has it corrected it? Here we go. Death. Now it says time smoking versus age. So it's corrected it. Okay. And the final thing we have to do in main is actually change the label on this graph. There's a label for it. So this is just the name of the graph here. But under data, it still says quit attempts. And we will say time smoking. Time smoking. Okay? Or years smoked. How about that? Years smoked. That's a better.
Cute.
So smoked meats. Yeah. Okay, ladies and gentlemen, years smoked. So now if we run this model, we should see those names corrected, okay? There we go. So, there we go, year smoked. Okay, now, you'll notice I'm panning around this model quite a bit. I'm sort of using this right click. It's pretty cumbersome. It's much nicer if you could pull things down. And this is actually an area where I've long been willing to not worry about things. So this is an occasion where Winchell is actually going to take the lead in telling me what to do. The only thing is he doesn't know that he's going to do this. So Winchell, I believe I know how to do this, but you're going to tell me just to be sure. If I want to make it so I can navigate quickly to this graph, I need to go drag into that a marker, right?
Just right.
And where are they located in this palette?
I think it's in the. It's in the view area. View area.
It's in the view area.
Oh no, it's presentation. It's view area.
Okay, view.
It's just.
Oh, view area. This thing. Okay, cool. Yeah. So I could place this down here, and then I give it a title, right?
Right.
So I say like years smoked versus age at death graph, something like that, right? And by so doing, by dragging that in and giving it a nice name, and I should really give it when it says view area, this is like age smoked at death view area. I'll give it a name that's distinctive because there may be many view areas in my model. Okay? Okay. So, ladies and gentlemen, here we have this label, and that label lets us quickly navigate to that place. So having put that down, having given it an appropriate title, I can now run this model. And I can click here, and I can choose that, and I can get up there. Do you see that? It's a nice way, particularly if you have lots of visualizations. Winchell's models are recommended not only by exquisite logic, excellent design, but also by exemplary visualizations. And he's made heavy use of these little markers to kind of zoom around, as have several of my other students. But I've been hampered by persistent lack of curiosity in that front. They came out long after I started using AnyLogic, and I just never. Okay. One other point remark that I probably should have included in my retrospective, but just should have noticed. This is again an emergent pattern from the model. There's a story behind it. To interpret it, there's, it bears when you see patterns like this, which exhibit real structure, to understand why do we see this structure? What is this telling us, in terms of this structure? And one of the things that this is telling us that I didn't harp on yesterday, but I could have, is the fact that there's actually not only this upwards gradient, which reflects the fact that someone can't smoke more years than they've ever lived, but not only this somewhat slightly downslope gradient, which means the longer you smoke, the shorter your lifetime is. There's also a very sharp gradient here. You notice this? What is that telling us? What is that telling us, that we have this spike here? There's actually, I don't know if you could see it, but by the way, with AnyLogic, you can go and choose additional controls often. With this mechanism, this will allow you to, for example, zoom in ways that otherwise might have been unavailable. I'll get to why those were unavailable. What does this say that these go way up here, but then very quickly it's sort of even slightly off here, you don't get people extending way up there. Why is that? Sorry? Yeah, these are never smokers. If you smoked at all, that is, you had your smoke that's more than zero, even if you quit very quickly, now you're a former smoker. And former smokers in this model, ladies and gentlemen, are saddled with, are encumbered by risks that are very significant. So they have a mortality for their hazard rate of 2 compared to the reference one of 1 for never smokers. Just that first cigarette marks you, well, okay, and depending how we designate initiation of smoking. And think of does the GATS define first 100 cigarettes? Is
5 packs.
Sorry?
5 packs.
Five packs, okay. As being marking initiation, but if you cross that barrier, suddenly your mortality hazard is much higher. Do you see that? That predated our introduction of this much nicer measure, of a measure that's actually far better, which is this cumulative time to smoke. And if we're going and recalculating death periodically, rather than having your probability of death depend only on the current smoking state, which you might still do for current smoker because of such active impacts, it might depend instead of depending on former smoker as a category, just on cumulative time smoked till now, which would capture the historic portion as well, the fact that, I did smoke before. But if this is minimal, cumulative time smoked till now, I smoked 6 packs in my life, then maybe cumulative time smoked till now will be very small, and I could factor that into mortality. It would just be a very small contribution rather than a large contribution like it is now. If we were to do that, by the way, probably that should be cumulative years smoked till now. We could readily do so. We could have some component for their current state and some component for their historic state. Would you like to do that? You want to do that? Okay. It will take about 5 minutes to do, I think. So if that's okay. Okay. Actually, I'm going to defer the gratification for one moment, though, if I may, because I want to make one other mistake. And this mistake, ladies and gentlemen, is a mistake not in our stars or any logic, but in myself. Okay? I did something that was logically incorrect yesterday. In Winchell, as one recognizes, as he is wont, spotted it and corrected me in sotto voce. Ladies and gentlemen, in your model, maybe I accidentally misspoke to Roberto. I'd like you to go to population. Could you go to population? And I'd like you to go look at birth time. What do you see for birth time? Do you just see minus age distribution? Do you see that? Or do you see time minus? Okay. Yeah, because I think what Winchell had spotted is that yesterday I had said it was just minus age distribution. Excuse me. Okay. That actually is fine, because the only time this gets used is at time 0, when it's equal to minus age distribution. So it actually can be minus age distribution, because this is the characteristics of the initial population. So that actually would work fine for the initial population. But it's really for the population as they come in. So that's when this is used. It's for the initial population. Sure, we could do it with time, but it's actually, time is always 0 here. But we could be changing our definition of when the starting time is. That's fine. But let's go look at immigration event. This is where I think the problem was. Is that right, Winchell? Yeah.
No, we had time there.
Did you have time? Okay, so you actually had it.
Yeah, I've never used your model.
You've never used it. Okay, good. You've been untainted, and you have it correctly. Okay, cool. Well, okay. Sorry. No, that's great. So, yeah, I don't know. Winchell pointed out that I think mine still had minus age distribution or something. Anyway. Okay. Oh, okay. Okay. So anyway, this should be time sense age distribution because they're coming into the population now at this age. So they were born at the current time minus this age to come in at that age. Okay. So that's good. I will note one other thing though that someone else had come up here to point out. Jerome, I think it was actually that came up and pointed this out. So there's a disconcerting factor going on here with his point was with respect to the immigrant population, but I would say it's even with respect to the initial population. Ladies and gentlemen, when the initial population starts in this model, in what state do they begin with respect to smoking? They're all never smokers. They all come into never smoker. See that? Similarly, I might add, over here, they all start in a non-pregnant state. More than that, per Jerome's point, for those who are immigrating, where do they come into the model? They all begin as never smokers because they are introduced into the model in the freshness of their form, starting as a never smoker because they start coming down. So that often flies in the face of what we want to achieve. And there's several ways around this, but the most elegant way is something that's straightforward. May I show you how to accomplish it? Because it's a common need for empirically grounded models. Okay? Before I do that, I'll just note that there's a tradition in modeling that is not uncommon to simply deal with this issue by saying, we are going to avoid trying to go through and initialize everyone coming into the population in the right way. Because it can get quite complicated. As Jerome pointed out, those people coming in should not only logically be starting in different states, they should further be starting with some cumulative times smoking till now. So that they're sort of comparable to the rest of the people in the population, rather than being, sort of special sorts. And folks who are unnecessarily, unrealistically healthy, etc. And it's an interesting point. There's a tradition within modeling. If this is something which only applies to the initial population, one way we try to get around it for some models is to run the model for several decades before we start recording data from it. We have kind of what's called a burn-in period. So we burn it in by basically running it until the initial population is kind of well mixed in terms of its characteristics. It's not showing the artifacts of its original state that they all started non-smokers. We want to run it for enough years that they kind of equilibrate. Very common in statistical simulation. And quite common in parts of discrete event simulation, in Markov modeling, etc. You run the model for some time. And we could do that. Another common need is you're interested in getting that initial state to start in a more representative state. What you do is you actually run the model with a burn-in period. You run it for a while until it's really well mixed. It's really well equilibrated. Then you capture the distribution from that model of cumulative time smoking. You might think, well, why do you have to do that? Because the numbers seen for cumulative time smoking in a given population are reflective of of birth rates, of death rates, of quit rates, relapse rates, all these different things, and trying to predict this from closed principles about what distribution we should draw from is very difficult. But you can, in fact, collect an empirical histogram from the model at a later time, at a time after burn-in, and then impose that as a pretty good starting point for the model. It's going to be pretty close to equilibrium. And Winchell, in fact, has engaged in said behavior on some occasions with recent models, sort of grabbing a characteristic of the population after some burn-in period and then using it for the initial state. Yes, Roberto.
Can you include the age of immigration? The age at immigration event?
Can you include it in?
The age of the
Yeah.
person at
Yeah.
when the immigration event.
Mm-hmm. Yeah. So can you include it in what?
I mean, in the model. I mean,
Oh,
we're
yeah,
talking
it's
about
included.
The smoking event.
Yeah.
The person arrives at age 20.
Oh, you're saying could you consider that and like where to put them in the state? Oh, I think you'd have to. This is you'd want to do it by have them distributed according to age for a realistic model.
My question is,
Yeah.
you have a person who immigrates.
Yeah. Yeah.
And at the moment you assume he's a non-smoker.
Yeah.
But that depends on the age.
Well, yeah. This is what I'm saying. You'd need to take age into account
Okay, so
normally.
you need to include the age into that event. Can you do that, or you need to include?
Well, age is already included because we already have for all the people coming in some age associated with them, and we would probably use that to determine, based on their age, what's their likelihood of being a current smoker or not. Yeah, exactly. So we could use their age to do that quite readily because they already do have an age coming in. And we could look up for that age what will be the probability that they're a smoker, and that's when I say a cumulative time distribution, it would probably be specific for different age groups, and similarly the likelihood of being in different states. Yeah. Okay, but what I'm going to do is I'm going to show you how to do this in a way that initially is going to just distribute it among these categories randomly. I will also talk about how you could do it by age. Okay? Okay, so here we're going to go. This is a very simple solution, and I think it's a fairly elegant solution. At least it's less bad than the options. Okay. Okay. So I've pulled up this entry point, and we're going to put in something which we haven't included yet, but we're going to include later today on additional occasions. So if you go down to the state chart, or if you went to the agent palette, we could pull in a branch. Do you see that? Do you see the branch? I pulled in a branch from here, I dragged it in and docked it. Notice when you drag these things into AnyLogic state charts, you need to make sure that they dock properly with a green docking indication. If it's only white, then that's an indication that it may be adjacent, but it actually hasn't connected to it. And there are times where it looks like it's connected visually, but you'll actually see that it's not yet green. Let me show you an example without asking you to do this. If I pull this out and I pull it, come on, I pull it back in. Okay, it's not. Oh, come on, cooperate. Here, watch this. Okay, I'm just going to create a fake state chart just so you can see this effect. I think I've seen it quite a bit in this occasion. So I'm going to copy this, paste it. Come on. Okay, where'd it go? Sometimes when you paste, you don't know where these things went. In order to find them, you have to go look over here. Okay, here we go. Unresolved. Yeah. Okay. Yeah. Fine. Okay. I'm going to go here. I'm going to call this. Watch this. Okay. I'm going to try to move this around. This is something where it's very close, but it's actually not connected. Now it's finally connected, not connected, connected. It turns green. Don't do that state chart yourself. This is just to show the phenomenon. Okay, ladies and gentlemen. Come on. Here we go. Okay, so what we want to do here is to take this branch, and the branch is going to have one default connection and then a set of conditional outcomes. So I'm going to go to the palette. I'm going to drag a transition to go here. I'm going to drag a transition to go to this next one down. And I'm going to drag a transition to go to the final state in that state chart down here. Now you may be aesthetically shocked by my actions, but don't worry, we're going to remediate them. So, ladies and gentlemen, when you drag these things, I often just focus on getting them connected at first, and then I bend them to my will, quite literally. So watch this. So I dragged it down to that. I'm going to double click along it. And then double click, it'll create a handle, and I will bend it as I see fit. Next, this guy here, I'm gonna drag him out here and drag it. And it actually yields aesthetics that are not altogether unpleasant. However, the fact that those are dotted lines, ladies and gentlemen, is troublesome, because that means that each of those is based on a default. You'll notice for each of them it says default. They're each thinking that they're going to be the one that occurs if nothing else, no other conditions are met. You can only have one default, only one dotted line. Okay? So what we're going to do is we're going to change the others to be conditional. Are we okay for that? Okay, ladies and gentlemen. In order to do this, we're going to add, this is a pattern. This is a modeling pattern that Winchell of which he should take note, because sometime Winchell we're going to compile a list of these patterns and provide them to people. I'm going to aesthetically frob it. Okay, ladies and gentlemen, this is part of a pattern. Another part of the pattern, so the first thing is you set up a branch and you create transitions to each of the states to which it could go. Second part of the pattern is you're going to devise a mechanism to tell it which way to go. Apologies for my English lapse. You're going to tell it through which path it should travel. In order to do that, we're going to need to encode a way for it to tell the state chart, hey, go this path, hey, go that path. Are we okay for that? This is how we do that. We go to the model, we say new option list, and we're going to say initial smoking state. Remember, an option list names a set of outcomes. Winchell, I was hoping you could research enum maps and their use with option lists. If you wouldn't mind looking into them. Enum map in Java, yeah. You could do that at sometime today. Thanks. Okay, initial smoking state. This could be never smoker. Never, but we want to name this in a way it won't clash with this never smoker. We'll say never smoker initial state. Or maybe we'll say initial state never smoker. No, we'll just say never smoker initial state. That's fine. Okay. I spent actually a fair bit of time thinking about names, because names are really, once you pick them, you live with them for a long time, and it's worth picking them carefully. They can make the difference in the model being inscrutable, opaque, versus it being really quite clear what's meant. And so they're not small matters how you name things. Former smoker initial state, current smoker initial state, never smoker initial state. Those are the possible initial states, okay? Another way you could have said is initially never smoker, initially current smoker, initially former smoker. That might be nicer, don't you think? Saying initially. Okay, I don't, it doesn't sound like the crowd is going wild. So I'll just say finish, okay? Okay. Okay, ladies and gentlemen. Next, so we've just created a way of naming what's our initial state. How are we going to communicate from main to person which initial state to use? What's a way we communicate from main, set certain things so that person knows about it and can use those accordingly? What other things does it set? A what? A parameter indeed. Thanks very much. Thanks. Thank you. Okay, ladies and gentlemen, let's go to the palette. Let's go to agent and let's drag in a parameter that's going to be initial smoking state. Are we okay with that? Guess what type this will be? Will it be a Boolean? Will it be an int, a string? A what? Initial smoking state. Now some of you may be wondering, why not use an int? Well, it's going to be clearer if we use named things, but there's something more than that we'll get to in just a minute. There's a good reason for doing it this way. Initial smoking state. That's what sort of type it will be. And maybe by default we'll make it never smoker initial state if no one specifies what it is, but we're going to specify for sure. Okay? Great. Next. So that's part 2 of the pattern. Well, actually, part 3. So part 1 of the pattern, Winchell, could you take this down? Part 1 of the pattern is you create a branch and place transitions to each possible state. Number 2 of the pattern, you create an option list that names each of these possibilities in a way that won't conflict with other names. Number 3, you add a parameter that will actually hold one of those values. Number 4, we are actually going to use the value of that parameter to dictate through which connection we travel. Okay? So here we go. Okay. So for this one here, so we're going to choose one of them to be the default state, the one that by default we'll say never smoker. And for the others, we're going to specify a condition. So you have to go and specify a condition for them. Okay? Do you see that? Condition. And the condition will be, is the parameter equal to the appropriate value? So is the initial smoking state parameter equal to current smoker initial state? TA should be ready to deploy it for rapid deployment. Strap on your parachutes. Okay? So here we will be routed to this state if the parameter tells us to go to the current smoker initial state. Do you see that? This parameter is going to tell us where to go. For this one here, we're going to have a condition. And what's the condition going to be here? Sorry? Speak on. Sorry? Former smoker. Thank you. Former smoker. Initial state. Okay, ladies and gentlemen, build. Okay. Notice it was unhappy. It was unhappy. Okay. Here. I'm going to close this. Hey, come on. Close. Okay. It was unhappy. Mine was unhappy. It's unhappy because add population needs to take that into account. That'll be the case, but otherwise it should be okay. Okay. Winchell?
Yeah.
Okay. Next step. Go fix up any places where the person is created. There's basically two major places that a person is created. Well, okay, three places in this model where a person is created. Where are they? Yeah. The initial population. Okay. Here. The initial population, ladies and gentlemen, we need to pick the initial smoking state. Do you see that? Do you see that? For the initial population? Initial smoking state, yeah? Okay. In order to pick this, actually, Winchell, before that step, we're going to add a custom distribution. And now the final motivations. This is going to be initial smoking state distribution. Now we could have we could have a different distribution for immigrants and non-immigrants, for example. Okay? And most typically we'd have this by age group. So for those less than smoking age, you wouldn't have any smoking. For those between a certain age, you'd have more, etc. And this is what Roberto was asking about. So here's the initial smoking state. For simplicity in this example, we'll just use it for the for immigrants and non-immigrants for the whole population. And this will pick, what sort of distribution will it be? Continuous, discrete, or options? Options. And what will be the option list? Initial smoking state. So here, this will specify what fraction are in each group. And maybe we'll say, 90% are in the never, were it only so in our societies. We'll say 3% in the current and 7% in former, or something like that. Actually, I think it's in the happenstance of what we have in our models. It's different from that, but we'll leave it like this. Okay. So this is a distribution of where people will be smoking when they get added to the model. Does that make sense? Okay, we're almost done. We're almost done. Next, we fix these things up to use that. So we go to the population, and when we create the initial population, guess what we'll do? Instead of just saying everyone's never smoker, what will we do? We will draw from this distribution that we just created. Okay, that's for the initial population. Where else do we have to do it? Where else are people being added to the population? Where else are they being added to the population? Yeah, immigration. Good. Let's go add it to immigration. Now, this is one of its complaints. It says add population is expecting, you could see, this is its error message. Add, you notice I went over this little X. And it says add population needs a sex, a double, and initial smoking state. And we're only giving it two things. We're giving it a sex and this time, this birth time. So we need to specify initial smoking state. Well, that's no problem. How are we going to do that? Time to draw from the distribution. So I'll put it up on the big screen. Okay, here we go. Okay, mumble. Okay. Go. Boom. Hey, give me it back. Okay, here we go. Boom, 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 boom. There we are. So this is the first argument to it. We're picking their sex of the new person coming in. We're picking when they were born. and we're picking their initial smoking status. Are we okay with that?
Can I ask a question?
Can.
When you add the population, how many, wrong question. Is that the add population will allow you to choose those properties if you predefine it, or you can just add it along the way? I don't, it's not very clear. So do you have to predefine those property, sex, age, and smoking state before you can actually get this command to
Add the person. So when you, this is a good question. When you add them, they're going to have some values for those parameters, and you can actually you can elect not to specify them now, in which case they'll get default values for those parameters. But generally, you don't want to do that because that will start them off with weird status. Like you could do this, in fact.
Right, yep, okay.
By the way, there's an underbar here. It's just for reasons puzzling to me, it's not showing it. But there's an underbar there. But yes, you can in fact do this, but generally you don't want to do that because you want to start them with their characteristics. Okay, so ladies and gentlemen, here we're drawing from this distribution, this initial smoking state distribution, much like we did from the sex distribution. And similarly, I want to do the same basic thing at what point? What's the third route of entry?
Pregnancy.
Pregnancy, indeed. And here for pregnancy, we'll go over to here. And here we'll go add that into the pregnancy situation, okay? Now, ladies and gentlemen, sometimes it can become a little bit ungainly, this add population, because it has so many things. Often what I like to do, Java doesn't care if you spread things out between multiple lines. So I like to put often these things lined up to line up each successive argument like this. So now you can see, okay, the first thing we add is a draw from sexes. The second thing is basically, the birth time. The third thing is a draw from this initial state. Yeah.
Shouldn't this one be never smoker? The child is already.
Oh! Good call. Good call. It would be a scary world if they came in smoking. Yeah. Thank you very much. This should be never smoker initial state. Yeah. Good call. Good call. Yeah. Yeah. Immigrants may come in smoking. And this goes a bit to Roberto's comment, though, which is a good one. Often we want to take into account covariance in characteristics more broadly between age, for example, and smoking status. Maybe between age, sex, and smoking status, right? Maybe if we're dealing with a smoking situation which is highly gendered in a society that it's mostly men who smoke, we don't want to be adding tons of women, just rolling a die for whether anyone in the population smokes, using the population prevalence as a whole to determine women. So we'll have conditional distributions. Any logic, despite Jeff and my exhortations, they've added some things over the years which are quite nice in response to our prodding from the health science side, including multiple types of networks, sexual network, IDU network, for example, et cetera. But one thing they haven't done yet is provide really good support for multivariate distributions. And so what you end up doing is you decompose it into conditional distributions and marginal distributions. So you successively decompose it. If you have what you'd like to have is a joint distribution, by sex, age, smoking status. You decompose it into age, or into sex, and then age given sex, and then smoking status given age and sex. And you know, it's more cumbersome than I'd like, but you can get by. You can get by. Okay. Anyway, okay. So let's run this now. So here we have a person. Let's rehearse, or let's go over what went on. So, ladies and gentlemen, we added a parameter which basically tells someone in what initial state, what should their initial state for smoking be. Based on the values of that parameter, we route them at the initial time when they come into the appropriate state. And we set the values of that parameter for people in the population at the time of their birth, immigration, or initial coming into the model. We draw from a distribution for that. Okay. So this will allow us to capture that element. Now, Jerome's other question about cumulative time smoked, capturing that is a harder. I mean, it's readily done. It would just, we don't have time to go do it now, but one could use a similar parameter approach to initialize the value of that variable. Okay. Interestingly, now we've seen that slightly distort our picture here. It's kind of interesting, actually. So now we have some individuals who have smoked a little bit. Of course, yes, and reach an old age. What's going on with that? Well, some individuals are coming into the population quite old and as smokers, and they only smoke for a few years, and then they die. They've achieved artificially, a long life because we haven't taken into account the covariation between the likelihood that they'll still be alive and their smoking status. I think that's a lot of it. But let's now add in. I promised. Add in, ladies and gentlemen, this component so that we'll have the mortality vary by cumulative time smoked. What do you think? Are we okay with that? Okay, so I'm going to stop this recording here.